Hello everyone, today I'd like to talk about architecture. One of the main questions that I receive a lot in when I start to work in a job or when someone enters in a company is, what do you do as an architect? Why do I need an architect in my company? What is your role? What do you do? Are you a very high skill technical? Usually it's the first thing that people think about as an architect, is that it is supposed for me to know everything. And they get surprised when I say to them, I don't have to know about everything. I understand the technologies. I know a lot of different technologies, but I expect the people that work with me to be better than me in their own jobs. I need someone that is really good in React, really good in Go, really good in Java and Spring Boot, really good on databases, better than I. I don't want to know more than them. Let's say my vision or my role is not to be better technical skilled on those areas, but to take the right decisions on those areas. It's different. Of course, you need a lot of experience to take good decisions, because the decisions are not only technical, but they transverse to business and other areas of your company. And that's what, if I have to create a kind of a definition or explanation about what an architecture does, let's say it's a kind of a glue between the technical team and the business team, and make sure that there is let's say the perfect, there is no such thing, I know, marriage, or at least the best that we can arrange between business and the technical part. But let's see in detail. I created a set of slides to explain better with some definitions, some diagrams, and so to try to give you a view about what it means to be an architect in computer science. Then in further videos, I will go into more detail, which patterns, which are the things that usually an architect should know, what patterns, architecture styles, and things like that. And in those ones, maybe you can get, I hope you really can get technical skills, or at least technical vision about the components, architectures that exists if you want to be an architect, or maybe you are already an architect, you just to listen to a different view, maybe you want to comment, maybe you want to discuss something with me, be free to watch my videos. Okay, so let's start with this one. So what it means to be an architect in computer science. And what we'll do is just to exploring the strategic. This is a very precise word to define an architect: technical and organizational dimensions of software and systems architecture. It's let's say a very nice definition with a lot of buzzwords, but let's see in detail what it means. So what is architecture in computer science? Architecture defines the structure, the components, the relationships, and guiding principles of a system. I would say that probably this is the most important. Not these ones are not important, but guiding the principles of a system, because it will be the paradigm. It will be, let's say, most of the decisions will be taken if they are matched to the guiding principles that were created when an architect decides what should be the way, the implementation, or the systems that were chosen, and what are the relationships between them, and things like that. So I would say that these four, let's say, points are really important, but the guiding principles, it's probably the most important. So at the end of the day, you can start to say that an architect is a kind of a leader that creates guidance or gives guidance to the other people, to the company, related with the alignment between business and the technical aspect. So it's the blueprint that balances complexity, performance, maintainability, and scalability. That's a lot of things to think about, but that's the job of the architect. It's not let's say, what is the best algorithm here? What is the technology that I should choose? It's more than that. This is just a small part, and we have to combine all of these things and take a good decision and create principles to guideline our solution. So it goes behind code, beyond code, not behind, beyond code. It connects strategy, people, and purpose. And this, for me, it's probably the most important in architecture. It connects strategy, because there is a strategy behind the decision. I would say that most of my decisions are not the decisions that were my first thought, because after I talk with stakeholders, leaders in the company, people that are not technical but they are paying, maybe you have to change your technical decisions, technical components, technical approach, the cloud that you choose, and things like that. I remember that I was once working with AWS from Amazon, and I had to switch to Azure because of a business requirement, not related to the technical, but there were some agreements between the company and Microsoft. So we have to choose Azure, and now our decisions will be about Azure, not because it's better technically. It's a nice cloud. It has great services. There is nothing wrong to say about it, but some decisions are business oriented and not technical oriented. And of course, I should connect with people. Let's say, okay, now do I have people for the Azure? Do I have people if I choose this database? Do I have people if I want to use Kubernetes? And that's really important. So I have to connect to this dimension also. And then we have the purpose. What is the purpose of this solution, of this system? And this is the most important because it will guide every decision that you have to take. I remember that sometimes even today when I'm in some meetings, people say, oh, it will be great to have this and this feature and to do things like this. And I always ask, why? What is the purpose of that? That purpose fits with the business alignment, with the business strategy, with the people that are involved, with the strategies that we have. If it doesn't, it's a nice feature, but there is no reason to implement it. And it's very cool. Sometimes developers don't like it because they like to use their knowledge, the best trends and things like that. But that's not the role of the architect. The role of the architect sometimes is just to take a bucket of wash and drop above everyone to say, okay, let's get it cold and let's take a decision that aligns with the business strategy and not the things that we know or we understand that are great from the technical point of view. So too much talk now, let's go into more details. So let's see some common components in architecture. You have client layer. This is maybe an architecture more software design, but there are some things that usually as an architect I have to think about. I think about the client layer, what will be the technology on the web app, if there are mobile applications involved, and mobile, it's a completely different market with specific decisions that we should take careful. It's not like building a regular web application. Then we have kind of a delivery layer, if you want to call it, but these were are the API gateways, what protocols are used, the security, the routing, if you are using cloud, multiple cloud, things like that. Then we have your business, let's call it service layer, like backend services. But of course, we need infrastructure that supports all of these and how we will be building the CI/CD pipeline. And this precedes a complete different area that an architect should understand. It doesn't have to understand how to create scripts in Terraform and things like that, but it should know enough to talk with the DevOps people and people that work in these areas. So, and then of course, as an architect, I should know about what is AWS, Azure, the difference, what are the advantages. Even Google Cloud, it's not here, but it's also viable in projects. Then we have monitoring. It's really important because of the observability. You want to understand how the system is behaving, what are the metrics, is it becoming slow or not. These are all a lot of things that are not related with the solution, but they are as must or probably, I wouldn't say more important, but without them, it's very difficult to have a business solution. And then you have the data layer if you want to use cache, object storage in clouds, relational database, NoSQL database, or file systems, what type of file systems. They are blob, they are NFS and things like that. There are a lot of decisions to take, but these are common components in the architect. There are a lot more than these ones, but that's the view that usually an architect should know. If you are a person that wants to be an architect, and if there is something here that you don't know, maybe you should study it. I don't know if you are already ready to be an architect, but it's a start. Sometimes people ask me, when do you know you are an architect? First, assume that you are, and now study for it as much as you can. So you start to be an architect. I have this profession to be an architect and say, are you an architect? Okay, I think I'm an architect good enough for most of the solutions, but I'm sure there are better architects and more senior architects than I. Okay, that's always so. It's an ongoing learning, let's say, journey when you want to be an architect. So why do we need architecture? Systems evolve. Architecture provides stability and direction. That is really important. That's one of the main things of the architecture. So when an architect is deciding something, he says, okay, how stable it is. It's can I evolve this architecture easily? Okay, what is the direction, what I want to target? Sometimes I take a decision that I don't know. It's not the final decision. It's not the best decision. But for now, it's the minimal decision that we should take. Maybe we want to check how good it is, if it fits our purpose, if it fits our strategy, and then we can take decisions later. Don't approach as an architect something like, okay, I want the best decision and the best product here with everything that we can. No, it's the opposite. You start very small. You should be very careful about your decisions, small ones, but because the decisions that we'll take have a very big impact on the solution. Imagine that you take a decision, say, okay, should I use Kotlin or Java, or should I use Go or Python? And that it seems very a simple decision from a technical point of view. If I ask to a developer like this, if it's an AI guy, we will say Python for sure. If you go for people that are microservices, they will say Go for sure. But you cannot take decisions based on the technical skill of the persons or their opinion. You should say, okay, let me see which people do I have in my company? What support do I have for this language? If I have a problem, can I call someone to help me to resolve the problem? If there is a bug in a framework, what is the time to fix those bugs in the community? 1 day, 1 week, 1 month? Because at the end of the day, we're creating business to receive money. And there is a bug that we cannot resolve or depend from an external entity. It has a very high impact. So sometimes small decisions can take a big impact and a negative impact in the business. So be careful when you take them. So systems evolve, as I was saying. Architect provides stability, which is really important, and the direction that we want to follow. So helps to manage complexity of modern systems, and they are really complex these days. Time and resource constraints, that's one of the most important, and this is always one of the strongest facts to take decisions. It's the time and resource constraints. It's always related in the architecture. Yeah, I have a great solution, but we only have 3 months to go to market. So we have to trade off a lot of things. Changing requirements, we have to make sure that the architecture fits new requirements quite well without doing breaking changes or something that puts the integrity of the solution in case. And aligns technology decisions with business goals. This is the definition of architect and architecture. Technology decisions with business goals, the alignment between these two, that's the role of the architect. It's the guy that it's in the middle. It's almost a manager. It reached the high point in the technical design, and now he doesn't want to be a real manager, but he wants to be a manager from the technical point of view. So it does this bridge between these two different areas in a company. So the architect's role, a senior technical leader who defines high-level structure and constraints, connects business, again, the alignment between business and technical, dev teams and stakeholders. Stakeholders is everyone, technicals and non-technicals. People that you probably don't know, like the customers of your website, and you have to understand all of them. Maybe you can do some surveys and things like that to try to understanding, or tests A/B. There are a lot of strategies that you can use to check the interests of the stakeholders. Now evaluates trade-offs with strategic foresight, again the strategy here, and architect is about intentionality, purpose, right? Always ask why this choice. This is the most, probably the question that I do most in the meetings. People sometimes they hate me for this, but that's the question I have. Sometimes I propose to do things. Why? I want to develop tests for this. Why? And I want to understand why. Why do we want to? Because it's nice, because everyone does it. That's not a good solution. That's not a good explanation. There should be an alignment between what I'm proposing and the direction, the guideline, the strategy, the business alignment behind the proposal that is being made. So this is one of the most important things. That's why sometimes people don't like the architects, because they refuse a lot, but there are reasons for they to refuse what they are refusing. And if you ask them, they can explain to you if you want. Maybe you don't like the answer, but they will explain to you. The Power of Why. There is even a book about why. It's a great book to read. And the architect, it's probably the word that architect always has in his mind. Every architectural decision should answer why this technology, why this structure, why now, and what happens later. Architects about navigating trade-offs. Every time you do a why, you have to take a decision. And you have to take a decision, it means that you have a choice. Something that you will choose, and other things that will put apart, even if they are the best ones in a specific set of context, but maybe it's not the context right now, and you have to do a trade-off. You say, okay, it's not the best at the base, but we have a small budget, so we go with this database. That's the trade-off. And the why? The money. There are always these two words, why and trade-off. There is no perfect solution, only choices with consequences. And that's the eternal job of the architect, and it's not easy to follow it. So key areas that architects address, there are a lot of areas, a few examples like business goals, technical strategy, stakeholder communication. Stakeholders are it's most important. And the area of system design, we have infrastructure, operations, monitoring and observability. Observability is quite popular right now. Security, one of the most important nowadays. Data architecture is a big trend right now. Developer experience, and there are others, but usually I would say these are the main ones. But if you want to split it, the main one, it's the business, because you do things for the business. And now you have two things that you should understand as an architect. One, it's the strategy, the technical strategy to align with the business goals. And of course, to create this alignment, you need to talk a lot with the stakeholders. You have to understand their interests. And remember that sometimes the stakeholders are people that you don't know, like end customers that you should understand them, and there are several ways you can do. Maybe you should talk with marketing teams and things like that to help you on that. At least they provide you reports that can help you to take better decisions. So architect versus developer. So if you are a developer, what are the main difference? So the scope, system-wide, I will say even enterprise-wide. We have to understand everything. Developer, feature or model level. It's more at the project per se. Responsibility, decisions with long-term impact, and this is a very strong point here. Short-term deliverables. Focus, architecture design, trade-offs again, scalability. The developer implementation, correctness, and speed. That's what they expected to align with the architecture focus. Stakeholder interaction, frequent, developer occasional. So usually the architect talks a lot with everyone involved in a project. Developer, it's occasional, sometimes goes to a business meetings, analysis, requirements, things like that, but that's it. Core responsibilities of an architect: evaluate and select technology stacks, and I'm always studying to understand what is new, what is the correct use case to do this, how stable it is, how popular it is, and things like that. So I have more tools to choose and try to find the best solutions for the stakeholders. Define system-level patterns like microservices, modular monoliths, and a lot of different ones, as you probably know. Write technical blueprints, architect decision records, and other kind of diagrams. Lead quality attribute discussions like performance, scalability, security, observability. These are really important, and usually they have an impact even on the way the software is developed and which stacks are chosen. Sometimes people, they say, I will decide this and then I will do the performance, scalability, security, and observability later. Sometimes it's the other way around. An architect starts with this one, saying, how many requests do I have? So what is the best framework for this? In what language? It's not what language, what is the framework, and how can I scale it? It's the other way around. Of course, now you have something like, okay, do I have people for that? Can I hire people? No. Okay, maybe I cannot choose this tech. So what will be the trade-off here? I will choose a different framework. What do I lose? Maybe I have to scale differently. Maybe I have to put in multiple clouds. Maybe I have to create different applications or different models. Maybe I have to split these into websites because of this. There are other decisions that came after we do this analysis. And collaborate with project managers, developers, security, operations, and so on. Communicate and justify the why behind every choice. This is the question that most stakeholders have. Why did you decide that? Why are we using this model? Why do I have to take this technology? Why do I have to pay monthly to the cloud? Why don't we put our data center locally? Things like that. That is always the why. Okay, dimensions of the architecture, technical, something that you should be aware: patterns, protocols, infrastructure, maintainability, scalability, everything that is technical. From the organizational point of view, something that interferes with the decisions, like the team skills, which people do I have, ownership, onboarding, do I need other people, when they enter, how much time does it take for them to be comfortable with our current software, communication overhead, the Conwan's law. This is a very, I will talk about more deeply about this kind of laws that exist in organizations. But let's say that the organization usually maps somehow the organization of the teams with the technology that is being used. And yeah, sometimes it's not the right approach, but it's quite common to see that. And from the business point of view, are we creating value? Meaning, will we have profit with the solution? Cost optimization, what is the best solution so I don't have to wire anyone else? Can I use my current resource so I don't have to expend additional money to create this project? And competitive positioning, customer value is something that it's expected for an architect to understand, even if it's not technical. But remember that the architect solutions are about business and earning money. So if you want to be an architect, start to think like a business person. Try to understand what is his purpose, what is his motivation, what is the business of your company. And when you start to talk in that language, people listen to you and stop seeing you as just a regular technical developer guy. And maybe they start to invite you for other kind of meetings if you have business ideas, and they start to understand how to implement them technically, how to create synergy or take advantage of the current systems and extend them with new things. That's one way for you to reach the position of architect. If you are an architect, you already know what I'm talking about. So the why, the most important thing on the architect, the why behind every decision, justifying trade-offs. You have to explain why you took a decision, avoid over-engineering, align with context, constraints, goals, and values. Everything that I was talking about in summary here, if you want to understand why the why. Let's say like this. Let's see a case study, very simple one. I will not provide. This is not a real one, just to understand usually what an architect does. Don't take this case study and the solution as a real good solution, because probably it's not. It's more about questions. I didn't put here a complete use case. I will in a future video provide, let's say, an exercise like a system design. I even have some videos about system design that I will probably create some use cases and good decisions. Not the best one. I don't know what is the best one. It depends a lot of factors on the company and the context, but there are usually some guidelines and common patterns that we can use, let's say, to try to reach a good solution. So let's say you have a SaaS task management platform. Usually I think it's the hello world of every use case, which is a task management software task management platform. So goal, build a scalable, secure task manager for SMEs. Constraint time to market. I only have 6 months. I have four full stack developers. This is my budget, very low. Target user, 1K teams in 1 year. And we should take technical decisions based on these constraints. The constraints are not about we have to use Python or we have to do something. But of course, if I have 4 full stack developers, I have this budget. It's saying a lot. Four full stack developers with this budget, they will be very junior, so don't expect a big project. So probably one of the solutions will be to have just a very small set of features, but quite effective, so we can have 4 full stack developers, not high skilled with this price, and to be done in 6 months. That's one of the things that you can take from these constraints. And this is one of the jobs of the architect, or one role of the architect is to try to, let's say, read between the lines. And when you start to understand this, you are going forward on your architecture goal. Stakeholder map, product owner, feature roadmap and priorities. You need a product owner. It doesn't mean that you have a full-time product owner. Sometimes the architect can be the product owner. It's not a good idea, but in small companies, why not? Sales team, customer expectation, integrations, okay? Developers, buildability, tech stack preference, or their knowledge, because probably we use, if you have 4 developers, you say, what technology do you, what is your preferred technology, or where are you good? And we probably will choose that one. Of course, and in a first approach, let's see later if you can or not. End users, UX, performance, mobile readiness, investors management, cost efficiency, and monetization. How can we earn money from this? Because you are spending this money, and of course we want some profit from it. Initial architecture vision, let's say front end, React. With this, maybe React, it's very popular, so there is a high probability of finding people if you don't have, or at least our full stack probably, they learn quite easy to React. Backend, Spring Boot, it's a great way to start a website, because Spring Boot provides out of the box a lot of functionalities without developing too much. I have a set of videos, dozens of videos, but Spring Boot, if you want to to check them, and where I explain why it's a great tool. There are others. It's not I'm using on a daily basis. I've used it, Spring Boot, .NET Core. I also use .NET Core. It's quite similar in some of the things. I use Go sometimes in some services, Python, and things like that. It's not that I'm promoting Spring Boot, but usually Spring Boot, it's quite reliable, strong. There are a lot of big community on Java, so it's quite easy to use it, and the community is big. So it's one advantage. Sometimes people don't like Java because it's too verbose compared with other language, but it's stable, reliable, well tested, solid, and when you want fast without or you have afraid of surprises, I would say try to go with Java. It's not my preferred language, but I have worked with Java for several years, and it's always a good bet in any project. Authentication, OAuth 2 for single sign-on, Google, Microsoft, GitHub is also possible. I wouldn't say GitHub it's a good solution for enterprise, but others for sure are. Maybe Google, it's quite used as a single sign-on service. Who doesn't logged in with Google in a specific website? Database, Postgres, because it's a strong database, it's free, maybe it's a good choice. I use it a lot in some projects. Infrastructure, you can go AWS with out-of-the-box containers, with RDS for Postgres, S3 buckets if you need files, uploads, and things like that. And Terraform, maybe it's quite advanced, but if you have a good architect that understands about Terraform that can use to deploy these things, and it's multi-cloud, so it's a great approach. CI/CD like GitHub Actions, Docker, and ECR/ECS for AWS. GitHub Actions is quite easy to create pipelines. With this and Docker, it's quite popular. So this can be an initial architecture vision. It doesn't mean it's the final one, but it can be a great start, and probably the difference between what we are approaching now and the final decision wouldn't be so different as we expect. Why this tech? Dev familiarity, speed. Spring Boot, it's quite speed. React, it also belongs to our full stack our four full stack developers. So mature ecosystem, Spring Boot, it's very mature. The AWS is very mature, so the risk is low of something to appear that we don't have a solution for it. And cloud manager service, cost-effective scaling. One of the advantage of the cloud is that we don't need to let's say, to manage infrastructure on our side. You don't need too many people. You need just someone that understands how to deploy things on a cloud. And the rest, let's say, part of it, it's one advantage of using cloud. It is managed, troubleshoot, and things like that by AWS, Microsoft, and so on. So key architectural decisions that an architect should think about at first. So backend stack, Spring Boot for rapid dev and maturity. The thing that I explained earlier, use hexagonal architecture to isolate business logic, but there are other, even a three layer probably, or monolith will be a good solution. How to decide this? I've created a set of videos on my channel about decision frameworks. Sometimes people don't listen or don't watch these videos because they think it's about management. But no, even as a technical person, you have to take decisions. And if you understand about decision frameworks, how to decide things, what is the approach that I should take, maybe it helps you to take decisions. For instance, in this one, you can go with something like the first principles decision framework, very popularized by Elon Musk, where you start what is true about your people that you have, the money that you have, the context of your company, to take decisions from there. Okay, maybe if your team doesn't know about hexagonal architecture, maybe you don't want to go this and you just go a three-layer monolith application at the start, and probably it's enough depending on the number of users that you want and what is the future, what is your goal. If this application scales to different models, or if it always be the same model, maybe you can change to a different architecture. But always be true about the facts that you have and take decisions from that. That's one of the first principles architect. There are other decisions framework that you can use. Database, normalized schema for extensibility, add Redis for caching frequent queries. Most of the queries in the task management suite will be quite similar. So probably when someone logs in, they is usually looking to his own tasks. So cache can be a good addition. Of course, you should do tests to make sure that you want to add Redis or not. Or maybe you can start the website without the cache and add it later after you collect some metrics, statistics, and say, okay, usually a person does 10, 20 queries about this data, and it's always the same. People are getting most of the time in these countries or these entities or these categories that I define, so I can put all of this in memory. After you have some metrics, it will be easier for you to decide if you want a Redis or not, or other kind of cache system. Security, role-based access control, HTTP everywhere, OAuth scopes and audit logging. In the web, it is quite relevant to have audit at least, HTTPS, role-based if you want to put more than one people accessing the same data. If it's for a company, yes, there are information that some people can see and other people don't see it. So why? Faster development, easier onboarding, safer deployment. You can see that everything that's used here, it's quite popular and with a big community, so the risk will be very low and it fits our constraints somehow. Time to market, fast, just a few people, low budget, and the target user. So go safe on your decisions. Maybe it's not the best decisions here, the best stack to use, but considering the constraints, for you to align with the business, that probably the decision that an architect will take. It will not be popular between the developers, but it's the best decision for the company. So trade-off analysis, decision area, API design, you have something like REST, GraphQL. REST is simple, GraphQL flexible queries, how to decide between these, deployment, monolith, microservices. I would say monolith, taking the constraints, but it's a decision that you should take. So faster, minimal viable product, microservice feature scalability. Even you can start with this one and later migrate to this one. But don't say, oh, microservice is good, I will start with microservices. It will take a lot of time and a lot of maturity to implement it. Maybe it's not a good idea for a small and quick project that you need to create. DB choice, by the way, I present this use case scenario in my video and decision frameworks based on first principles, for instance. DB choice, Postgres versus MongoDB. Postgres relational integrity, everyone knows about relational databases. MongoDB, schema flexibility. We have more flexibility, but do we have people for this? It will be a real advantage. How can we check if it's a real advantage? How much it's a big advantage? There are a lot of questions that you should make before deciding this kind of taking these kind of decisions. CI/CD, Jenkins, VS, GitHub options. I would say probably GitHub. GitHub, it's direct. It's out of the box. It's there. If it's free, of course, you have more constraints. But if you are paying for a license every month, you have GitHub actions. You have a CI/CD out of the box. There are thousands of examples that we can copy paste from the internet and use for your project. So it will be Jenkins, custom workflows, integrated and simpler. Probably we should go simpler. Okay, risk assessment and mitigation. Risk, it's quite important in architecture. So every time you take a decision, there is a risk. Feature creep, too many features can jeopardize the time of developing. So mitigation, lock, minimal viable scope. You can use a decision framework here, like the Moscow principle, where you have this must go, should go, could go, or won't. Maybe you can take that framework for you to take these kind of decisions for feature creep. Lack of infra experience, mitigation, use managed AWS service. If you don't have people that understands how to do infrastructure, okay, there are out-of-the-box simple things that you can use in AWS or even Azure. Both, they have this kind of things that you just deploy there and that's it. The configuration, let's say 60%, 80% of the configuration is automated for you. You don't have to understand it, at least on a first approach. Probably you will if there is a problem, but you don't have to think in everything, create all the configuration files and things like that. Technical debt, mitigation, enforce code reviews and architect decision records, meaning you say, okay, to avoid technical debt, there are just a few people, but make sure that before any commit, someone looks into the code and say, okay, I can understand that code. It's not documented. Please do some tests on it. Make sure that it works. This method, it's too big. Just put it small so I can read it later. Change the name of the method. So it will help to grow the team later. And this is a concern that an architect should have. Okay, risk, scale, bottlenecks, mitigation design for horizontal scalability early. This is a decision that we can take, but it has an impact because horizontal scalability, meaning that you add other services on the side. So sometimes this can have impact in sessions and how you split the data that you are storing. Quality attributes to prioritize performance, async job queues, and the N+1 query prevention. I will talk more deeply about this in a future video about architecture, but sometimes people use things like Hibernate and object relational mapping. And when you have an entity that has a relation with other entities, sometimes, let's say, you just need the user information, but since there is a relation between this entity and, let's say, profiles and other details about the user, for friends, contacts, they bring this. And in a web with thousands of requests, it's not a good idea. It will demand a lot of memory. So it is called the N+1 query prevention. Try to design, if you don't need information, don't bring it. Don't load it from the database. That's the principle behind this N+1 query prevention. Security, input validation, outliers, encrypted storage. It's quite common. People should understand this. If it's a public task with sensitive information, of course, encrypted, it's the word. Scalability, stateless service, horizontal scaling, as we talked earlier. Observability, you have to understand when something wrong happens, what was the cause, what was the current state of the system internally. And you can use something like OpenTelemetry. Read from it. It's Prometheus, Grafana, they are tools. This is a standard. Prometheus and Grafana are tools. Prometheus is good for metrics, Grafana to create dashboards. OpenTelemetry, it's a way for you to collect logs, metrics, and traces from your application, so it will be easier to troubleshoot in the future. And I will have a set of videos just dedicated to OpenTelemetry in the near future. Why this? Align with business goals, user satisfaction, uptime, security, compliance. Okay, long-term architecture evolution, minimal viable product with modular monolith, plus feature toggles. I would say modular monolith. That was I proposed. When I look into the constraints, I already saw monolith should be the way to go. Move toward event-driven microservice if there are more services to have. If it's just a simple task management, I would say it will be forever modular monolith. But if you have payments, you have to integrate with entities and things like that, probably start to think about microservices, but move towards it. Add a new services, start to integrate both, and then don't try to refactor the architecture, everything. Just take decisions that will allow in the future to fit that, but don't compromise the feature or the time of the quality or it. Introduce message brokers like Kafka. I would say that you should use Kafka. Kafka is used when for big projects. It depends on the volume that you are receiving. For async workflows, adopt DDD for complex domains. DDD is domain-driven design, meaning it's very related with microservices also, not only, but if you are developing a microservice, you say this is just for task, this is just for payments, everything about payments, it's isolated from the rest of the world. And when I say isolated, it's API, the database, everything. It's like if it's a complete local application that understands how to communicate with the others. And why? Flexibility and resilience at scale. Okay, let's say again a simple architecture diagram. Taking this, so we have a web app and a possible mobile API gateway with the Spring Boot services, and a OAuth provider. It's one way to do it. So you can integrate with things like Google, single sign-on, for instance. At the data layer, a Postgres database, Redis cache. This could be one solution, one approach to our problem. It will be easy to implement. The API gateway, it's out of the box in any cloud. Web app, React, it's quite common for the web. If there is the need for mobile, of course, we will need someone for the mobile. OAuth, we have a lot of things already implemented. Even Spring Boot already integrates quite well with the OAuth and integrates with Google and other GitHubs and other single sign-on systems. And the data layer Postgres, it's free and it's quite popular, very compatible. It supports relational and no relation. You can use JSON, things like that in the Postgres. I know that there is something if you want to integrate some AI. I know that Postgres is a model for vectorization of queries. And of course, if you need cache, you have the Redis cache. It's quite popular. So soft skills of a great architect: strategic thinking, empathy, and active listening. Again, strategic thinking, you don't see too many technical here. Strategic thinking, empathy, and active listening. For you to have a strategic thinking, you have to understand how business works, how to take decisions. That's why I introduced my set of videos about decision frameworks, how to understand system design and things like that. It's quite important. Empathy and active listening, communication. You have to listen. Active listening means that you have to check every comment that a stakeholder provides to you. Maybe a small one can have a big importance. Okay, because you don't know behind stakeholders. Sometimes there are retractors and things like that you have to detect. There are people that want for the project to be successful. Other people don't. People sometimes they say, okay, you shouldn't think like that. You should think like that. That's one of the things, because when you are a developer, you don't care about that. But if you are an architect or business decisions, at the end of the day, there are people, and there are people that want success and other people don't. And you have to check them and understand how to handle it. it's quite important. Don't be naive. We are people, okay? We have our own agenda. Conflict resolution and compromise. Why do you think conflict resolution arises if everyone was good people? That's the problem. And compromise, cross-functional communication, mentorship and knowledge sharing. This is one of the things that I think brought me to architecture. I always had, let's say, kind of a pleasure to teach people and share my knowledge with people, like I'm doing now, for instance, when I'm creating these videos. So architect tools, diagrams, C4, Plant1ML, sequence diagrams. I use a lot tools that are, let's say, diagram as a code. I like to program my diagrams. Let's say documentation, active decision records. It's a good, very simple way for document architecture decisions, RFCs, architecture roadmaps, frameworks like TOGAF if you want to understand enterprise architecture. I wouldn't say that you should be certified, but if you read it, you understand better what is architecture somehow. Flosspolar and vModel, Atom, there are a lot of frameworks that you can use. TOGAF, probably it's the most popular one, I would say. Maybe there is another one, I don't remember now the name. It's based on vectors, Zackerman, I think, something like that. And tools like ArcUnit, something that I will talk about. It's unit testing for your architecture. SonarQube, I use it a lot to check to have a dashboard for the quality of quality, not testing quality, but for the code of applications. Swagger for APIs, Terraform for infrastructure. So final talks, to be a great architect in computer science, think in systems, not just services. System is the word here. Balance constraints with creativity, communicate clearly across all levels, not only technical, business, other people, everyone in the company that have interest in your solutions. Always ask why. This is an articulated trade-offs. This is one of, I will say, if you read about architecture, what to be an architect, probably this will be always the sentence that will appear, okay? And design today with tomorrow in mind. So we have an objective, a goal, and now you go backwards and try, okay, I have to decide this, I have to trade off this, I cannot implement this at this right time. I will create, I remember that I was working in a bank as an enterprise architect with other enterprise architects also, and some of our documents, they have a kind of 3, 4, 5 phases. And we say in the first phase, we'll do this. It's a minimal viable product. Then we check the results and we review this. And now you can take several decisions here to version 2. So we understand what we wanted in 1 or 2 years, but we wanted to make sure that we approach that carefully with small versions until we reach them. It can be the case that we projected 5 versions, but after the second, we'd say, okay, you cannot follow this path. We should change our path. If you start to go globally and say, I want the full implementation now, and then at some point, okay, you can follow the Pareto law, which says that probably with 20% of your features, you can achieve 80% of the stakeholders' interest. So start with the 20% and go from there. Okay? So thank you. Let's build resilient, scalable, meaningful systems together. I know this was a big video. I hope you had the patience to listen to all. I provide a lot, I think, value information if you want to be an architect. Usually I don't do videos with 40 minutes, almost 50 minutes, but this one, I wanted to make sure that you understand what is to be an architect with a use case and things like that. And if you are interested in to be an architect, I think I provided all the information, let's say start information for you to think about and to understand better what is to be an architect. My future videos on architecture will be very small. I will target specific things like architecture style, specific patterns, laws, CAP theorems and things like that, things that you should know if you are an architect or you want to be an architect that challenge you. I'm always, in parallel, I'm creating other videos when I have time about decision frameworks, system design, thinking in systems and things like that, that I think you can profit from them to bring more tools to your mind so you can take better decisions. So thank you for watching this video, and I hope to see you in my next videos about this subject.